Hello students, welcome back to my channel Engineers Academy. Kindly subscribe my channel for the solution of such more problems. Now I am going to solve this problem. In this problem it is said that the combined drive wheels of a front wheel drive automobile are acted by 7000 Newton normal reaction force and a friction force F, right? So this is 7000 normal force and this is the frictional force, and it is said that both of which are exerted by the road surface. And it is said that if it is known that the resultant of these two forces makes a 15-degree angle, right? So the resultant of both of these two forces are making 15-degree angle, right? So let me draw that resultant. So that resultant will be acting in this direction, right? And it is said that the resultant of these two forces making 15-degree angle with the vertical, right? So then we are given this angle, right? So this angle is 15 degrees. And it is said that determine the equivalent force couple system at the car mass center G, right? And it is said that treat this as a 2D problem, right? So now to replace these two forces by a force couple system, first we will find the resultant magnitude, right? So this is the resultant, right? So now as we can see, if this is 15 degrees, so then this 7000 Newton is the cos component of this resultant, right? So I can say that R cos of 15 degrees equals to 7000 Newton, right? So this will give me the magnitude of the resultant of these two forces. So R will be equal to 7000 divided by cos of 15 degrees. So this R equals to 7246 Newton, right? So this is the magnitude of the resultant of these two forces, right? And if we want to find the magnitude of this friction force, right? So from this we can say that this force is the sine component of this R, right? So I can say that F is equal to R sine of 15 degrees, right? If this is the cos component, so then this is the sine component, right? So R is 7246 sine of 15 degrees. So this friction force is equal to 1876 Newton, right? Now we know the magnitude of this resultant, so then we have to find the moment produced by this R about this point G, since we want to replace this R by a force couple system at that point G, right? So first I will find the moment about G due to this R, right? So that moment about G will be equal to, if we use the Varignon's theorem, right? So this force F is equal to 1876 Newton, and let's say that the counterclockwise moment is positive. So now as we can see that this force F, this 1876 Newton, is producing the clockwise moment about this point G. So I will write minus, and this will be 1876, and the perpendicular distance of this F from that point G is this 500 mm, right? So I will multiply this with 500 mm divided by 1000, right, in order to have the answer in Newton meters, right? Similarly, as we can see that this 7000 Newton force is producing the moment about this point G in the clockwise direction. So I will write minus, and that is 7000 into the perpendicular distance of this 7000 Newton force from that point G is this 1000 mm, right? So 1000 divided by 1000 is 1 meters, right? So the moment, the summation of the moment produced by these two components of this resultant will be equal to the moment produced by this resultant, right? So this moment will be equal to the moment produced by this resultant, right? So this mg comes out to be minus 7938 Newton meter, right? And from this negative sign we can say that this is clockwise moment, right? So now to replace these two forces by a force couple system at this point G, so what we will do is that we will draw another force which will be parallel to this resultant force. We will be having this resultant force at this point G, and then we will represent that moment, and that moment is clockwise moment. So we will draw this, and its magnitude is 7938 Newton meter, right? And then we need to remove these forces since they are replaced by this force couple system, right? So let me remove these. So now this is the solution of this particular problem.